Hello everyone, this is Himabindu from the Department of CSIT. Today in this video I would like to describe about the regular languages. So here till now we have discussed about the finite automata. In that one, finite automata with output and without output, how many missions are there? Like with output we have the Mure mission and Mille mission. Those things are already discussed in the previous videos. And now what is meant by regular language? So what kind of languages are accepted by the finite automata? Let's move on to the slides. A regular language is a language that can be expressed with a regular expression. So here before going to the languages, we have to find what is meant by expression. So regular expressions are nothing but it is a pattern of input symbols. So it will be explained in the form of patterns of strings. So here, what is this regular language? So a regular language is a language that can be expressed with a regular expression or a deterministic or non-deterministic finite automata or mission. So here we have to discuss that regular expressions are formed by the strings. So here the regular expressions for the input symbols, whatever we have given in the finite states, those are all combinations of the strings. So we have to form the regular expression with the input symbols. So our next point is about a language is a set of strings which are made up of characters. So it is the language is nothing but how many strings which are involved in the construction of DFA or finite automata. So those are all symbols. Its collection, set of symbols are called as a regular language. And what third point is about the regular languages or a subset of set of all the strings. So here what is meant by a regular language in the sense it is a subset of set of all the strings. So what are the strings involved in that one? So it is a collection of subsets of the strings. And next, the regular languages are used in parsing and designing the programming languages. So where we are using these regular languages in the sense we are using in the parsing and designing the programming languages, and or one of the first concept taught in the computability courses. So these are the things which are described about the regular languages. Let's see some examples how to describe this language, regular languages. So here are the sets. So we have taken some examples. So set of vowels. So how many vowels are there? A, E, I, O, U. These are the vowels in the vowels in the alphabet. So there is a set of vowels. So how to describe the language of this set of vowels in the sense we are going to describe like this. So it's a combination of, it's a subset of the strings A, E, I, O, U. And one more example, A followed by 0 or more B. So A should be followed by nothing and also B. So that is the main notation. And here the A is followed by nothing, here nothing, and B also. How many times B? So it can be, what is the regular expression for this one in the sense A and B whole star. So like this we can form the regular expression by seeing the regular languages. So here these are the subsets of some languages. So here the subsets we can be declared in the form of regular language. Any number of vowels, third one, any number of vowels followed by the any number of consonants. So these are the vowels, and what are the consonants in the sense remaining, what are those having the all 26 alphabets, B, C, D, F, and so on. So these are all the consonants and these are the vowels. So it's a combination, any number of V is followed by any number of C. So any number of E followed, what are the symbols involved in this one in the sense nothing, and A, E, I, O, U. So it's a combination of all the, vowels, and it is a combination of all the vowels. And here also we have taken the consonants, and it is a combination of vowels and consonants. So here we have taken only consonants. So it's a combination of all the vowels and consonants. Like this we have to form the regular languages. And here is the diagram. We can represent the what is meant by regular languages. So it's a combination of regular expression and finite automata. So we can exchange this finite automata to regular expression and regular expression to finite automata. Those topics are all going to be covered in the next sessions. So, and here what is meant by regular expression? As we already told that what is the regular expression, in the sense it's a string pattern. We can say that it is a pattern of symbols. So we are representing the language in the form of expression. So that is a regular expression. And the finite automata, these topics are already discussed. It is a discriminate finite automata, non-discriminate finite automata, and epsilon NFE. So these are all the automata and missions. So if you combine both, we will get the regular language. So regular languages, these are all formal language classes. So this is about the regular languages. We can form, with these regular languages, we can form the regular expression and we can form the finite automata. Next slide. So regular expressions versus finite automata. So what is meant by regular expression? So regular expressions are used to generate the patterns of strings. So we already discussed it generates regular expressions generate patterns of strings. So it generates patterns of strings. And when coming to the finite automata, use it to recognize the pattern. So here, what is the difference in the sense? It is a finite automata we are representing with the FA. So regular expression which is generate the patterns of strings, and finite, whether the finite automata it recognize the patterns. So it is recognizing, the finite automata is recognizing the patterns, and the regular expressions or generate the patterns of strings. That is the difference between the finite automata and regular expression. Or offers a declarative way to express the patterns of any string we want to accept. And here what we have discussed. So here we saw that regular language, it's a it's a subset of 0, 1 and so on. 0, either 0 or 1. So it's for this one, what is the regular language in the sense? It's a combination of 0, 1 and 0, 1, and here it is a nothing. So we will discuss this regular expression, how to construct a regular expression in next slides. And here the regular expressions are more program syntax like. So here we are, why we are using this regular expressions in the sense we are in the programs, it is a syntactic representation. The programs are all syntactic representation. In the programs, we will use the regular expressions. And Unix environments heavily use the regular expression like Bash shell, grep, VI editor, and other editors. So these are the examples of where we are using the regular expression. And coming to the finite automata, as we discussed, finite automata are used to recognize the pattern, whereas the regular expression is used to generate the patterns of strings. And the finite automata, it more like mission. And if you give input as a string, you will get the output as a accepted or not. Mission, if you give this, if it is a FSM mission, so finite state mission, if you give input to this one, we will get the output as whether it is accepted or rejected. So this is about the finite state mission. So if you are giving the input as a string, if you give string as an input to the FSM finite state mission, you will get the result as a accept or reject. Whether this string is accepted by this finite state machine or not, it is the output for the finite state machine. And next, so what are the regular expression and regular sets? So as we already discussed, regular expressions, it is a declarative way to express the string what we want to accept. So regular expression, we are expressing that strings in a pattern. So patterns, we are declaring that the way of declaring the strings in the pattern representation is called regular expression. Any terminal symbol belongs to the sigma, including empty and null are also regular expressions. So these are the things which are with the regular expression. So regular expression is that any terminal symbols belongs to the sigma. So sigma is nothing but those are all the input symbols. So input symbols including pi and epsilon, null and empty, empty and null or also gives the regular expression. And next, the operations like union, concatenation and iteration or closure or of two regular expression is also a regular expressions. These are the operations performed by the regular expression. So what are the operations performed by the two or more regular expressions? In the sense, union operation, we will denote like this symbol, with this symbol union, and concatenation will just represent a dot, and the closure or iteration we will represent as a star. So these are the operations which are involved with the regular expressions. What are the operations? Union, concatenation and iteration or closure. So these are the symbols which are representing, we are performing some operations on the regular expressions. Like if you take the regular expression 1 and if you perform a union operation, we will write like this. And if you want to perform the operation concatenation, regular expression 1 dot regular expression 2. And if you want to perform the closure operation, we will denote like this. So these are the representations of the operations for the regular expressions. And coming to the regular sets. So any set that represents the value of the regular expression is called regular set. So any sets that represent the value of a regular expression. So if you take this as a, so in this so these are all the regular sets, we can say that. So it's empty symbol and null symbol and also 0, 1. If it is all the combinations of the regular expression is formed by this all the terminals. So we can say that it is a set of regular set is called a regular set. A special set of words over the input alphabet. So it is a set of alphabets to perform a regular expression. And next, what are the properties of regular sets? So here, what are the properties? In essence, we have the 7 properties. The first property is the union property, and second one is intersection. So the union of two regular set is a regular. So we have to prove that by performing the operation called union for the two regular sets, 2 or s set is also a regular set. So by performing union operations for the two regular set is also giving the regular set. And here this point we already discussed in this one. So when whatever the operations performed by this two regular expression is also a regular expression. So here also same thing. So by performing the operation of union for the two regular set, we will also get the one more regular set. And here also the intersection of two regular set. So intersection should be denoted by this symbol. And here if you take the two regular sets, we will get the regular set. And here the complement of regular set is complement. How we will denote? So we will take one language L. So we will also get the language that is also a regular language. And the difference between, so with the minus symbol we will represent the difference of two languages is also regular. And the reversal of, we can say that or this is also regular. And the closure of, so closure of this we will get regular. And the concatenation, so we will represent this concatenation of like this. We will get, this is also regular. And here those properties can be proven by this. We are taking these regular expressions with the three regular expressions what we have taken. So what are the three regular expressions? These are the regular expression, and for this regular expression what are the languages? So for, if we are taking the regular expression 1, a whole star. So for this one, a star represent, it is also nothing. So nothing, epsilon. So epsilon to a. So we are starting this a, and this a is, it is nothing but a two times, and so on. So like it is all the combinations of the strings of odd length. So if we see this, a is 1 and 3 times and 5 times. So the number is odd numbers, the odd number of length including null. And next language L2 is nothing but it is having AA. So and first AA whole star represent empty string along with the AA pattern, and it is 2 times. So we can say that 2, 4, 6. So what is the length of the string in the sense? The string of even length including null. And next, the string of all possible length including null. So here a star represents, a whole star represents, it is a combination of strings all possible lengths including null. So with this regular expression we will prove the properties. The first property is the union of two regular sets. So here we will take or L1 union L2. So we will get, so what are the combinations of L1 and L2? So AA and 5 times AA and so on. And union, so L2 is nothing but epsilon AA 4 times AA and so on. And here if you combine both, we will get AA. So here I am taking A 4 times A and so on. So this is represented as A whole star. And next, this is the first property. And next property is intersection. So intersection. So for the intersection, we are taking L3 intersection L2. So we will get what is the intersection of A, triple A and so on. And intersection. What are the common things involved in the two languages? So for the L2, so epsilon AA and so on. So here if you observe this one, both is having, what are the common things? So AA and this one. So it's all combinations of A. So even length and so on. So what is the regular expression for this one? A whole star. How it is in the sense? So A epsilon is also A, and this is the thing. And here also A, I'm sorry, this one nothing. So like this, we have to represent the regular expression for this intersection of two. So here this is also a regular expression and this is also a regular expression. By performing the two regular expression operations, we will get the another regular expression only. And next property is the complement of. So what is the complement of regular? So what we will get? So here the third property is the complement of regular. We have to prove that the complement of language is also a regular expression. So for this one, what we will see, the complement of what is the language, we have to uh, take this complement of regular language. What we will get? So here also we will see this complement of regular language 2. So what are the two language involved? And so on. So complement in the sense here is that there is a no symbols which are involved in this language. What are the input symbols? What are here? A is not there, and triple A is not there, and 5A's are not there. So like this, we have to note all which are not involved in this language. So what is this whole expression contains? A whole star. So this is what we got L3. Sorry, L1. So here it is also. So here it is also a regular language. So this is proven. The complement of regular language is also a regular language. And next property is, so next property, the difference of two regular set is a regular. So difference, how to denote this difference in the sense L3 minus L2. So what we will get? So L3 minus L2 in the sense. So what is the L3 language? So all the possible strings which are involved with this L3 language, and minus what we have to do, we have to take epsilon AA and 4A's and so on. We have to take out this minus difference, and what we will get? A comma triple A and 5A's. So what we will get in the sense, it is a odd length. So odd length we already discussed as a L1. So what we will get? L1 like A whole star. So this is also regular one. So it is also a regular language. So what we have got? So by performing the operation called difference for the two regular expression, we will also get the regular expression. And next property is the reversal of regular language, regular set. So what is the reversal? We will take one language. So we will perform the reverse operation for that one, and we will get the again regular set. So reverse of what? Reverse of regular language, and we'll take the example 0, 0, 1, 0, 1, comma 0, 0, 1, 1, comma 1, 0. So this is the regular language. So, and what is the regular expression for this one? In the sense, it is all combinations of all these symbols. So this is the regular expression. For this one, what we have to do? We have to perform the regular reverse. So language reverse. So here what we will get? So for the reversing this one, instead of 1, instead of 0, we are replacing it 1. 1, 0. So we are just reversing the strings. So for this one regular expression, so this is the regular expression. And what is the language? So language is 1 0 0 0 1 1 comma 0 1. So this is also same as the language. So it is also a regular language. So like this we have to perform the operation of reverse also, we will get the regular language. And one more property, the closure of regular set is a regular. And here also the closure of regular set, so closure of reverse set, so closure of L star of star, we will get L star like this. And here also A star of whole star, we will get A A star. Like this we will get the operations, we will perform the operation and also we will get the regular expression. And one more property is the seventh property, the concatenation of two regular set is regular. So what are the two regular sets we have taken for this property? In the sense, regular expression 1 is 0 plus 1 star 0, and regular expression 2 0 1 whole star of 0 plus 1. And here, what are the languages for this regular expression? In the sense, it's a combination of 0 and, so either it is the string is going to be start with either 0 or 1, including with the epsilon symbol, and ending must should be 0. So this is the set. So what is a regular set for this language? In the sense, if you see, observe this language, it is all the strings which is formed all or ending with the 0. So for this one, what we are saying, the set of strings ending in 0, and it's a combination of, it is starting with 0 or 1 and with the empty symbol also. And what is the regular language expression 2? It contains the starting of the language should start with 0 1. So 0 1 including epsilon symbol, and also ending would be like either with 0 or 1. So it must start with 0 1. So what we are saying, that a set of strings beginning with the 0 1. And then if you combine both, so what operation we are performing for the two languages? In the sense, we are performing the concatenation. So concatenation should be denoted by the dot symbol. And if you combine both languages, what we will get? We will combine. So A 0 0 1 and 0 0 1 0. So we are performing first this, and so we are adding all this one. Like this, we have to add we have to combine both two languages. We will get the result like this. And by seeing this one, the set of strings containing 0 0 1, the starting of the language will get 0 0 1. So every time we are getting 0 0 1. So in this string, in this language, we will anytime we are getting the substring as a 0 0 1. So this is the pattern what we have observed for this. So for this one, how to write this regular expression? In the sense, it is a combination of either it is starting with, so here if you observe 0 0 1 is ending with a 0 and here the ending with 1. So we can perform this substring and either it is ending with 0 1 and 1, 0 or 1. And here also for the beginning of this string, this substring, we are starting with 0 and we are starting with 1 also. So for this one we are performing 0 plus 1 whole star. And also including epsilon. So here including epsilon in the sense, so for this substring there is no ending and no starting. So for this one we will represent this empty symbols, ending and starting. Like this we have to perform the regular expression for the given language. So these are the references where we have taken the content, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.